Hello my dear students, welcome you to the video lecture of operating system. In previous video lecture we have started 3.4 and next part of 3.4 we are going to discuss in today's video lecture. So 3.4 is related to threads. In previous video lecture we have discussed concept of thread, benefits of thread and types of thread, that is a user thread and kernel thread. Then in this video lecture we are going to discuss multi-threading module, many to one, one to one, many to many module, and its brief discussion about the multi-threading modules. So previously we have gone through this learning outcomes of the 3.4. So student can easily explain the concept of threads. Then student can explain the difference between thread and process. Then student can explain the benefits of the thread. These are 4 benefits. Then different types of threads, user thread and kernel thread. And last point, user can draw and explain multi-threading modules. So before going to discuss our basic aim of this video lecture, draw and explain the multi-threading module, we can revise the previous video lecture concepts. So thread is a lightweight process. It has separate program counter, code, its stack area and its register to hold the information. So it is a similar to process but it is a lightweight. Okay. So using the thread we can increase the parallelism in the operating system. So it supports multi-threading or multi-programming environment of execution. Then if there is a single thread, then every individual thread has a register, counter, stack, data and file, also code. If there is a multi-threading approach, then multiple threads have a separate register, counter and stack, but they share a common data and file. Also they can share a common code in between them or common code segment. So that is a diagram for single threading and multi-threading. Then a difference, we have already studied the difference and its parameter definition, interaction, sharing, blocking, resource and operations. Basic 4 benefits of threadings are responsiveness, resource sharing, economy and scalability. You can explain it in the proper wordings. So we have discussed these benefits in previous video lectures. If you have doubt, you can go through that video lecture again and clear that doubts. Then we have seen the 2 types of threads, user level thread which are executed at a user level and kernel level thread which can be executed at a kernel space. So user level thread, its advantages, its disadvantages. Then kernel thread which is managed by the kernel, its advantages and disadvantages we have seen in the last lecture. In today's video lecture our basic focus is on a multi-threading module and different modules in the multi-threading approach. So what is a multi-threading? So there are multiple threads executed at a time. So that is called as a multi-threading. So we have previously seen the diagram. So it can have separate register, stack and program counter, but they can have a common data and file and they can share a code segment between them. So that is a multi-threading approach. In some operating system it provides combination of user thread and kernel level thread facilities. Solaris is a good example of combination of this approach. So Solaris is one operating system which is a combination of user thread and your kernel thread. In combined system, multiple threads within the same application can be run parallelly. Multiple processes and blocking system call need not block entire process. So multiple threads can be executed parallelly at a time. So that is the basic theme of multi-threading, and it may have a user thread and it may have kernel thread. So basically there are three types of threads. So in multi-threading approach we have three modules. Many to one means many user level threads and it have a single kernel thread. One to one means one user thread must have a one kernel thread, and many to many user thread have many kernel thread. So that is basic fundamental concept of threading. So my dear students, I have previously discussed this concept because if you want to execute a user level thread, there must be a kernel level thread. So every user level thread has its appropriate kernel thread in the kernel space. Okay, so depending upon that concept, we have three modules: many to one, one to one, many to many. So it is a user and kernel relationship. So many user thread may have a single kernel thread, one user thread has a one single kernel thread, or many kernel threads or many user threads have many kernel threads. So that is a execution approach, because in some condition if you want to have complete execution, there must have required a kernel thread. So in operating system, every user thread has a kernel thread. So that is called as a multi-threading approach, because it is a combination of user thread with a kernel thread. So that is the meaning of multi-threading. So multiple user threads at a user area may have a single or multiple kernel thread. Okay, so depending upon the combination, we can execute that threads. So it may provide a parallelism, high speed execution, responsiveness, okay, economical, very cheaper, okay, it shares the resources and scalable. So that are the advantages of multi-threading. This is a diagram of multi-threading approach. So there may be have multiple user thread, and multiple user thread may have multiple kernel thread. So basically there are only three approaches: many to one, one to one, many to many. Okay, so one to many is not available. Okay, so my dear student, user thread, single user thread cannot have a multiple kernel threads. Okay, so that is a very important point. Multiple user thread have a single kernel thread, single kernel thread have a single kernel thread, or many kernel thread, user thread have a many kernel thread. Okay, so there is an approach which is not available in the module, that is a one user thread cannot have a many kernel threads. Okay, so this is a basic theme of multi-threading modules. So first module is many to one. Okay, so in this module, many user level threads mapped with a single kernel thread. Okay, for execution of multiple user thread, it has a single thread in a kernel area. Okay, so that approach is called as many to one. So multiple user threads having a single kernel thread in the kernel area for execution. So if one thread is blocked, one thread is in the blocking causes all blocking. Okay, because if kernel thread is blocked, then all user threads are blocked in the many to one approach. Multiple threads may not run in the parallel on the multi-core system, because only one way or one kernel can execute a one thread at a time. Okay, so that's why multiple threads can have a single kernel thread. In few systems like a Solaris green thread, JNU portable threads, this many to one approach is used. So in many to one, you can write down the definition: multiple user threads have a single kernel thread. If one thread is blocked, all threads are blocked. Only single thread can be executed at a kernel time. So the parallelism is there, but multi-core system must have the parallelism. Okay, and examples of many to one modules are Solaris green thread and GNU portable thread. Okay, so that is a many to one. Okay, my dear student, in MSBT question paper, this question is asked multiple times. So what is mean by multi-threading? Multi-threading is nothing but multiple threads are executed simultaneously or concurrently, parallelly at a time is called as a multi-threading. So in which every user thread has the appropriate kernel thread mapping. So we have many to one, one to one, many to many module. So in many to one, many user thread has a single kernel thread. If one thread is blocked, all threads are blocked. So single thread is executed at a kernel time. Few systems are using this approach. The examples of these systems are Solaris, green thread and GNU portable thread. Diagram is very important. Okay, so you can have a square area. So it is a user area and it is a kernel area as that of previous diagram. So that is a mapping. Okay, in second module, one user thread has a one kernel thread. So there is a one to one mapping. Each user level thread mapped with a kernel thread. Creating a user thread creates a kernel thread. In this approach, it is more concurrent or parallelism than many to one. Okay, number of threads per process sometimes restrict due to overhead. Okay, so problem in this system or in this module is if number of user thread increases, that will automatically increase the kernel thread. Okay, so every user thread has its unique or it mapped with its unique kernel thread. So every user thread has its unique map of kernel thread. So that approach is called as a one to one. It is more concurrent than the many to one. Okay, but overhead of multiple kernel threads in this module. Okay, so example of these operating systems are in Windows, in Linux, in Solaris 9 and later versions. The one to one approach is used. So that is a one to one multi-threading module. And next, many to many module. In the many to many module, many user level threads map to many kernel threads. It allows operating system to create a significant number of kernel threads. Okay, so a single thread or number of threads can be mapped with the number of another threads in the kernel area. So that approach is called as a many to many. It will be quite complicated, but it increases the concurrent execution parallelism. So basic examples of this many to many modules are Solaris, previous version of 9 and Windows with thread fiber packages. Okay, so in Windows which supports thread fiber packages will support many to many module. Okay, so these are the three modules. I have explained with the proper diagram and its features and examples. So there is a task to my student find out the advantages and disadvantages of these modules, because it is very easy to find out the advantages and disadvantages. Okay, so I can give you the hint of this exercise that you can have a complexity issue, then overhead of kernel area, okay, then parallelism and concurrent execution. These are the four parameters through which you can find out the advantages and disadvantages of this module. Okay, when there will be question in the MSBT question paper to explain the modules, multi-threading modules, then you can write down the definition of thread first, then what is meant by multi-threading, then list out the three modules, then every individual module with feature and diagram explain appropriately with proper example. So you can add two advantages and two disadvantages in this answer also. Okay, generally it is asked for 4 marks, so there is no need to add advantages and disadvantages. If it is asked for 6 marks, then you must write down the advantages and disadvantages of every individual module. Okay, so this is a multi-threading approach. Okay, and you can draw these diagrams or you can use this diagram also. Okay, so for many to one you can draw the multiple threads here and you have only single thread, so you can use this diagram to demonstrate the threading module also. Okay, so many user thread, single thread, many user thread, many thread, or many user thread have a many threads. Okay, so there are only 3 approaches. Okay, many to one, one to one, or many to many. If there is a one to one, then you can have this type of diagram. Okay, every individual thread has its mapping kernel thread, so you can plot this diagram or you can use these simple diagrams which I have shown, which I have explained in your elaboration. Okay, so diagram may reflect your knowledge, so you can draw your conceptual diagram also. Okay, which will help to explain your concept. Okay, so in operating system, diagrams are very important. Without diagram you cannot explain anything. When you are explaining, you must include some features, then advantages, disadvantages, and some examples. Okay, that will give out of marks. Okay, also you must draw or you must have a habit to take a notes and key points from the video lecture. That will help for your MCQ type examination also. Okay, so my dear student, you must prepare for theory exam as well as MCQ exams. Okay, so key notes, your notes are very important. Okay, so I can conclude this video lecture and 3.4 is over. Now single point is remaining in this chapter, is 3.5. In 3.5 there are some commands which controls the process or which manages the process. So in next lecture we can discuss this command, and then we have a practical session on 3.5. Okay, till then stay at home, stay safe, stay healthy, happy, learn.